Good morning, gentlemen. We're going to continue our quick discussion of acids and bases. Let's start with the review of what we've already done. So real quickly, we defined acids as those things when you put them in water, like HCl, they form hydrogen ions. And in this case, it forms Cl ions as well, but the hydrogen ions are what make acids acids. If we know the concentration of the HCl in this case, or the acid, we also know the concentration of the hydrogen ion, because in this case the ratio is 1 to 1. So the stoichiometry within the equation tells us for every 1 mole of these, we have 1 mole of these. So if the concentration is 0.5 molar of HCl, we know the concentration is also, 0.5. Let me erase that. 0.5 molar of H's. And then we also learned that if you know the concentration of the hydrogen ion, you can figure out the pH, because we know pH is equal to the negative log of the hydrogen ion concentration, which we just said is 0.5. So if we want to calculate the pH of this 0.5 molar HCl solution, we would hit the log button, we would hit 0.5, hit our equals, and we would get negative 0.3. And since we're taking the negative of negative, it would simply be a pH of 0.3. Bases work very similar. So if we take a base like NaOH, we put it in water. We said that bases are those things that form hydroxide ions. So in this case, here's our hydroxide ion. And with sodium hydroxide, we would also get some sodium ions. So there's our sodium ions. So the OHs are what makes our bases basic. So, and the concept holds true as far as the stoichiometry goes. So if we had 0.5 molar NaOH, we would also have 0.5 molar OHs in that solution, because the stoichiometry tells us it's a 1 to 1 ratio. If it's a 1 to 2 ratio, then we would have to double that, and so on. What we haven't learned is okay, well, how do we figure out the pH of this? If the hydroxide ions concentration is 0.5 molar, how do we go about figuring the pH? Well, in order to do that, you need to be introduced to a little bit of equilibrium, which we're not going to do much equilibrium, but you need to know a little bit. So we have to talk about the self-ionization of water. So if we took a glass of water or a beaker of water, and we could watch the molecules and see what they'd do, they actually will do this. They will ionize on their own and form those two ions that we've been referring to. They form a water molecule, form a hydrogen ion and a hydroxide ion. And how that happens is it's really just one water molecule steals a hydrogen from another. So another way to show that is to put two water molecules in our equation, like this. And what happens is one of these hydrogens ends up going over to the other water molecule, and you end up with an H3O ion, which we've already said is essentially the same thing as our H ion and our hydroxide. That is called the self-ionization of water. Okay? The self-ionization of water is a equilibrium equation, meaning that it goes in both directions. So it has what we call a equilibrium constant, and all equilibrium constants are symbolized by K. And in this case, we're dealing with water. So the equilibrium constant for water is Kw. So, and you may not understand equilibrium, and that's okay. What you need to understand is this equation right here. The equilibrium constant for water is the concentration of the hydrogens times the concentration of the hydroxides. And that's been experimentally determined at standard temperature and pressure to be 1 times 10 to the negative 7 is the concentration of the hydrogen ions, and 1 times 10 to the negative 7 for the hydroxide ion concentrations. So what they're saying is that in water, the concentration of hydrogen ions and hydroxide ions are equal to one another, and they are equal to 1 times 10 to the negative 7th. The constant is simply the product of those two, and if we multiply those two together, we get 1 times 10 to the negative 14th. That is the Kw, or equilibrium constant for water. Now, how does that help us figure out pH? Well, we need to know the hydrogen ion concentration to figure the pH. If we know hydrogen ion concentration, we can figure pH. Well, what if we don't know it, but we do know the OH? Well, if we know OH, we can simply solve for OH using this equation. So we know the Kw is 1 times 10 to the negative 14. And we know that the Kw is equal to the hydrogen ion concentration times the hydroxide ion concentration. So we can solve for either one of these if we know the other one. So if we know the hydroxide ion concentration, we can solve for the hydrogen ion concentration. So if we just do some simple algebra, the hydrogen ion concentration is equal to 1 times 10 to the negative 14th divided by, we're dividing both sides by OH to solve for H, the concentration of the hydroxides. So if we know this one, the OH, we can solve for H. It's just 1 times 10 to the negative 14th divided by whatever the OH is. So let's try a problem. Okay, here's our problem. We have 0.5 molar NaOH solution, and the question is asking us, okay, what is the pH? What is the pH of that 0.5 molar NaOH solution? Well, in order to figure out the pH, we need to know the H, or the hydrogen ion concentration. And we can use the hydroxide ion concentration to do that, just like I showed you. And in this case, we know the OH concentration is equal to the concentration of the NaOH because of the 1-to-1 ratio. So we know if we take 1 times 10 to the negative 14th divided by our concentration of 0.5, that's going to give us the concentration of hydrogen ions. So you do have to remember how to punch that scientific notation into your calculator. If you're not using the EE button or your exponent button, I would strongly encourage you to use parentheses around everything. So I'll punch it in, 1 times 10 to the negative 14th divided by my 0.5. And many of you could do that in your head, but that's okay. We'll punch it in. That's going to give us 2 times 10 to the negative 14 is our concentration of H's. And then if we want to know the pH of that, we know pH is equal to the negative log of 2 times 10 to the negative 14th. So again, I put in log 2 times 10 to the negative 14th, and I get negative 13.7. So the negative of a negative is a positive. So 13.7 is our pH. And if you think about it, it makes sense. Look at this. It's a base. So its pH should be well above 7. And it's pretty concentrated base. It's 0.5 molar. Okay? All right, let's try one more. Okay, let's do one more here quick. So we have calcium hydroxide in this case, which notice we have 2 hydroxides in there, so it's not going to be a 1-to-1. So there's the equation. We'll say we have 0.03 molar calcium hydroxide. So there's our 0.03 molar. When it goes into water, we get 2 hydroxides, making our concentration 0.06 molar. So the question is, what's the pH of this solution? So if we're looking for the pH of this solution, we need to know the hydrogen ion concentration. And in order to figure out the hydrogen ion concentration, we have to use the hydroxide. So again, we'll use that Kw. So we know that 1 times 10 to the negative 14th for an aqueous solution or a water solution. The concentration of the hydroxide times the hydronium or the hydrogen has to equal that 10 to the negative 14. So we know this one, 0.06. So divide 0.06, that's going to equal our hydrogen ion concentration. So if I punch that into the calculator, I get a concentration of 1.66 times 10 to the negative 13th. So a really tiny amount of hydrogen ions in there. So even though this is a base, there's still a tiny, tiny, tiny amount of hydrogen ions in there, but a really tiny amount. Okay. So now to figure pH, we just take the negative log of that. So negative log of 1.66 times 10 to the negative 13th. I punch that into the calculator. I get a negative 12.8. So a negative of a negative is 12.8 is the pH. So the pH of that solution of 0.03 molar calcium hydroxide is 12.8. So a very, very high pH, which would make sense because look at all these hydroxide ions that are in it. It's a base, it's 0.03 molar, plus we get 2 of them. So going to be a very high pH. Very few hydrogen ions in there. Okay, well, today's assignment, you're going to do some very similar problems. The key's posted. So I am going to be offline for a few hours. They're shutting my electricity off. So you may not be able to get a hold of me email, but by afternoon I should be able to see emails. Okay, good luck.